Okay, well, welcome back, and we're going to talk about another rule which is known as the chain rule. Chain, 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 chain rule, chain rule. All right, so with that, what is the chain rule? Well, the chain rule is we are differentiating composite functions, And so if you can read up here, we have where we are taking if f is differentiable, so that's a function differentiable at a point u, which equals g of x, and g is differentiable at x, then the composite function f composed of g of x, which is this right here, is differentiable at x, and we write this. The derivative of f composed of g of x equals the derivative of f composed of g of x times derivative of g of x. So as I would say, you take the derivative of the outside times the derivative of the inside, baby, and you just keep on going through. Another way of looking at this is if you want to look at some differentiation notation. If y equaled f, all right, of u, all right, and u equal g of x, we can write this as, well, we're looking for a derivative right here, whoop, right, dy dx, which is going to equal dy du, so we're going to take the derivative of the outside function, because that's our f composed of u, all right, and then we have with respect to u. So that means we're taking it just with respect to whatever the inside function is. And then we're going to multiply that by the derivative of du over dx. And you see that right here, the derivative of the inside, which is u, with respect to x, which is g of x, well, we then get the dx and the du's would cancel out, and we're left with this. But this is kind of why the chain rule would work. Okay? So to help us understand that, we have to understand what a composite function looks like and what we're dealing with here. So here we go. Let's try some of these. So I only have a y equals sine of 7 minus 5x. And we see a lot of problems like this, a lot of trig functions. We're going to use composite. Now, here we can see that we have an outside function which we'll call y. So we're going to try to figure out what is y of u. All right, so y of u, all right, is going to equal the outside function. So whatever, how do you know, figure out the outside? Look at what is inside the parentheses. That is your u. So u is the inside function, and this is the outside function right here. Okay? And so we're going to have u, which is going to be 7 minus 5x, and we'll have y of u. If we take that out, we'll have sine of u. So what do we need to do? Well, we're going to figure out dy dx. So that means we have to take the derivative of the outside. So we need dy du times the derivative of du dx. And that is going to give us our derivative dy dx. So what does that look like? Well, the derivative of y with respect to u is going to be, derivative of sine is cosine, so cosine of u times the derivative of du with respect to x, so that means we're differentiating with respect to x, so that's going to be 0 and then negative 5. Okay? And so our final answer, when we want to put this back into terms of x, we're going to have cosine of u, well, what is u? 7 minus 5x times du dx, which is negative 5, and that, my friends, is the chain rule. Chain, 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 chain rule. All right, that's what we have. Let's try another one. If you want to try this out, you can kind of look at it. Once again, another trig function. You can pause this video before I go through it. So how do we know we have a composite function? Well, we have a composite function because we have cotangent and we have a function inside. Okay, we see parentheses. And so right here we have y equals, all right, let's find y of u. Well, maybe we should find u first. U is going to equal 2 over x because that's inside parentheses, which is also, I can rewrite this as a power function, 2 times x to the negative first, which we're going to do that. Well, if u is that, then what we have left over is 5 cotangent of u. According to the chain rule, my friends, I'll change my color here. All right, dy dx is we take the derivative of the outside, dy du with respect to u, times the derivative of the inside with respect to x. All right, and we go from there. So what we have here then is the derivative of y. All right, so dy dx is going to equal the derivative of y with respect to u, which is going to equal 5 as a constant, times cotangent. The derivative of cotangent is negative cosecant squared of u in this case. All right, times now du dx. Well, we're going to use the power rule. So we're going to have 2 times negative 1 times x to the negative second. Going to subtract 1 there. We can simplify this now, and I'll replace back my u. So I have negative 5 cosecant squared of u. U is 2 over x. So it's going to be right like that. Times 2 times that would be negative 2 over x squared. Simplifying that right there. Go a little farther. Negative 5 times negative 2 is 10. And we'll have that over x squared. I'll just bring that up to the front. And now we're just doing a little algebra action and simplifying that. And that would be our derivative using the chain rule. Chain rule. All right. Let's try this puppy. All right. Now, when a lot of students see this, they see secant times tangent. That is not correct. That is not correct. It's secant of tangent of x. Secant of tangent of x. I'm just going to write that again. Secant of tangent of x. All right. Of tangent of x. Okay. And so, what we need to do is we need to identify, all right, dy dx. Well, that's going to equal dy with respect to u times du dx. Okay? So what is our y of u? Well, sometimes it's easier just to find our u first. So find the u first. What's inside? Well, once again, you see what's inside parentheses, and you have a tangent of x. You have y of u. What's y of u? Y of u is going to be secant, the one outside, which is secant of u. So now when we figure out our answer, we're going to have dy du, which is, all right, going to equal, this, dy dx then is equal to derivative of y with respect to x. So what's derivative of secant of w? Well, that's going to be secant w tangent w times the derivative of u, right? That's right there, and which is going to be equal to secant squared of x. And so now we want to replace back all the values. What's w? So we have secant of tangent of x times tangent of that's weird. Tangent of x, all right, times secant squared of x. This is not tangent squared. These are inside of the function, but guess what? That's our derivative. This is a chain rule. Okay. We're going to try this one right here. Now I'm going to have a little power function, the square root. I'm going to pause this video. You can check it out and try yourself. This, once again, is a chain rule problem. We need to figure out what is our outside function and what is our inside function. Sometimes it's easier finding our outside function or our inside function first. So what's our u? U in this case is secant x plus tangent x because that is inside the square root. So then if we do that, what is our y of u? What is our y of u? Well, y of u is going to equal 4, and when we take that out, the square root of u, which is the same thing as 4 times u to the power. Okay, so now let's find our derivative. So dy dx, and just so you know, dy dx is the same thing as y prime, so maybe I'll start using that too, just so you're aware. Take the derivative of the outside. So what is dy du? Well, that's going to be 4 times the derivative of u to the 1/2, which is 1/2, power rule, u to the negative 1/2, subtract 1, right? Times now the derivative of u. Now, derivative of u is made up of two terms, two trig terms. So we have derivative of secant, which is secant x tangent x, plus the derivative of tangent, which is secant squared of x. So when we simplify this, we got to plug that back in there. So we have, I'm going to simplify why I do that. 2, what is u? Secant x plus tangent x to the negative 1/2 power times secant x tangent x plus secant we got? I think I got one more here for us to try. Okay. You try this one at home. Make sure you got it down. Figure it out. Okay. Once again, we have this right here. This kind of throws off students. But when you see that, that is just a constant. Those are just constants. Really what you should be focusing on is we have this constant times sine of 3t, then we have cosine of 5t. So we have two actually different composite functions. So we got to do, when we take the derivative of this, you get dy dx, all right, or dy dt, that is. Because now we're not using x, we're using t. We're going to take and do the chain rule twice. We have to do it twice. And so for the first one, if I look at this one, we got to figure out what our outside function is. So our outside function is going to be y of u. Y of u is going to be 4. We got this 4 over 3 pi times sine of u. In this case, our u is going to be 3t. Now for over here, we do the same thing. We got to go y of u. Well, y of u, what's the outside function? 4, 5 pi cosine of u, because that's the inside. It's in parentheses. U is going to equal 5t. And so when we find this derivative, when we find y prime, maybe we should change my color. When we find y prime, we're going to take the derivative outside 4 over 3 pi times the derivative of sine, excuse me, derivative of sine, which is cosine of u, all right, times the derivative of u, which is 3. And then we're going to add that to now the derivative of y of u for this one, which is going to be 4 over 5 pi times derivative of cosine, which is negative sine of u, times derivative of u, which is 5. We can simplify this. Excuse me. Again, sorry. Simplify this, and we have 4 over pi cosine of u, and u is 3t. And we're going to have 4. This 5's will cancel out, so we have 4 over pi. Oh, we probably can factor that out too if we wanted to. Oh, and I got a negative there, so I'll just put that negative here. Boop. All right, and we have sine of u. In this case, u is 5t. And there we have it. That's our simplified derivative. Pretty neat. Okay. Well, going all the way back to our slide right here, my friends. All right. This is the chain rule. All right. We're taking the derivative of composite functions. And you see a lot of composite functions everywhere you go. And so we can use that in many different ways. I have other videos on how to do this of more challenging composite functions. You can check those out. All right. Well, I hope this helps you out. And good luck and God bless the rest of your problems.